So in this presentation we're going to look at graph theory. This is the 2010 question. We're going to start off with some short questions. Let G be a graph and U and V be vertices of graph G. And first off, say what is meant by the degree of G. So this is just a short question. The degree of V. Essentially, the degree of V is how many vertices is V connected to. So suppose V is connected to 3 different vertices, we would say it has degree 3. The next part is, say what is meant by saying that U and V are adjacent. Suppose this is U here. U and V is the fact that they're adjacent. That didn't come out too well. The fact that they're adjacent is that they are connected by a single edge to one another. That is what is meant by adjacent. So they are connected by one single edge. Yep, so those are some short theory questions, always good to know. The next part is, state without proof a result connecting the number of edges of G with the degree of vertices. Now, suppose you have n vertices. No, sorry, that's actually not true. It's the sum of the degree sequence. So number of edges is the sum of the degree sequence. What's my spelling on? Degree sequence divided by 2. Okay, so if there is a degree sequence of 4, 2, 2, 2, and one more 2, let's say. Suppose that is your degree sequence. That means the sum of the degree sequence is 12, and that means there are 6 edges. So, number of edges is the sum of the degree sequence divided by 2. So you don't have to prove it or anything like that. Now the next part is, a graph is called k-regular if each of its vertices has degree k. Now, use the result from B to find the number of edges in a 7-regular graph with 8 vertices. So we have 8 vertices and each of them have degree 7. So it is 7 plus 7 plus 7 plus 7, so on. So we actually can write it as 8 times 7. Okay, and in that case, that is the sum of degree sequence, and that's 56. That means the number of edges is 56 divided by 2, and that's 28. Now, explain why it is not possible to construct a 7-regular graph on 9 edges. Okay, so let's just try and get the solution out first off. So 9, the sum of the degree sequence would be 9 by 7. 9 vertices, each of degree 7. That will give you a sum of the degree sequence of 63. So the sum of the degree sequence divided by 2 is 31.5. That's not viable. You can't have that. So, not viable. You can't have 31.5 edges in a graph. It must be a whole number. It must be a natural number. So that is why it is not viable. Construct a 2-regular graph on 5 vertices. Let's do that up here in the top corner. Oops. Let's do that again. So 1, 2, 3, 4, 5, and let's just add them all up together like that. So that is a 2-regular graph. Each vertex has degree 2. And there's 5 vertices. So that is the end of that one there.